I can move from here itself. Okay, because we already make a practice of here itself. So data 1 and data 2. Okay, the data 1 is for, it indicates like this. Data 2 is indicates for this. Okay, and parallelly we have to import this. Sorry, export this data 1 and data 2. Select all. Okay, export to workspace. Can you close it? And yes, we can able to find data 1 and data 2. So if you double click on data 1, okay, and parallel one icon will open in center of the variables. Yes, we have to paste your that readings. Okay, if you have the readings, no problem. Okay, if you don't have the readings, try to copy the readings or try to write the readings from the PPT and feed the readings in the variable space. This is the testament. These are two input readings. Okay, this is the input readings used for training. So what happens? Yes, I am moving here and again I place in readings. Okay, if you have readings, no problem. If you are not having readings, can you type the readings? And if you come to data 2, what happens? We have to paste all the outputs as like what we have done for input. Okay, so yes. Yes, we are getting the data 1 and data 2. Okay, are you getting or not? Good. After that, what are you going to do? Once you finish reading data 1 and data 2, what happens? Avinas, you can enjoy it at the exam point of view. I am the question. Okay, you will enjoy by seeing your marks. No problem. Okay, what happens? Yes, you have data 1, data 2. Okay, what are you going to do? What are you going to do? Now, when you wait for the network, so data 1 is there, data 2 is there, but it still is in the workspace. We have to import the data 1, data 2 from the workspace to here. Okay, what happens? Yes, import from workspace, data 1 as input data, import, and valid data 2 as the target data, import. Then, once you import that input data, target data, you can check it. Yes, I got these readings. Okay, and valid, I got these readings. Okay, understood or not? Once if it's finished, what are you going to do next step? What are you going to next step? What are you going to do next step? New network. Once if you have the software in your lab, yes, you can able to activate simultaneously. If not, means it's a problem. Okay, network. Your network is straightforward back propagation, that is multi-layer. Okay, after what are you going to do? Input data is data 1, output data is data 2. Straight LM, these are functions are mandatory. How many layers are here? Actually, what happens? A single layer behind 2 layers. Am I correct? But here behind 4 layers. That is behind 3 layers. One input layer, one output layer, and one return layer. If you come into single layer architecture, one input layer and one output layer. If you come in here, one input layer, one return layer, and output layer. Okay. So for 2 layers, okay, we have to enter 3 here in software. Okay. But even though you are not going to enter, we are not going to activate the third neuron. That is third layer. Yes, you can find here. So number of layers, how much? 4, yes. 4, enter it. After that, layer 1. How many neurons? How much input? 2. Okay, what's the function? Knowledge of dancing. Okay. Coming to 2, how much? So I'm going to vary the neurons. First I'm going to make an attempt with 8. Okay, so I'm typing 8. After that is also dancing. Okay, after that coming to layer 3. Layer 3, how much outputs are there? 5. What's the thing? Pure linear. Yes, layer 4 is you cannot able to enter anything. Okay, but keep it here as a pure linear. Okay, anyway, layer 4 is far. Okay, backup, but you are not going to enter any data in the layer 4. Okay, you enter only neurons layer 1, 2, and 3. But even though you are not entering any neurons in layer 4, try to keep it as a transfer function is pure linear. Okay, then create. Yes, recording data 1, data 2. Okay, and the network is we created a network with 8 neurons. Okay, we created a network with 8 neurons. After that, what are we going to do? After that, what are we going to do? Right network. Yes. Okay. Train. So we are going. So we are input layer. We are in output layer. We are in the input layer data. We are in the output layer data. And parallelly we are in the 8 neurons middle layer. We can fix 8 neurons middle layer, and we can fix the transfer function. So far we fixed the activation function. Now we are going to train. Okay, and we are going to predict the for 8 neurons. Train. Input is data 1. Output is data 2. Okay. Training parameters. Yep. Goal is 0.0001. The purpose is 1 lakh. Okay, and keep it also. MU is also 0.01. Once you finish, train network. Once you fix the parameters, go propose and MUM. Okay, yes, you can get this thing. Validation stop. That's finished. Okay, validation stops. Yes. Plus, yes, we are having some interruptions in the graph. Okay, we have to refer these interruptions, but for your subject is not needed. Okay, yes, I'm going to carry out the research work. Yes, you have to carry out some interruptions in the graph. Okay, the graph which indicates also performance of your network, but that's no need for you. Okay, so you can check it. It's coming right. Tick mark or red mark. Red mark comes in cross red color. That is cross mark comes in red color. Tick mark comes in green color. If it's finished, that's all. Okay. After that, what are you going to do? After that, what are you going to do? Yes, you have to create the outputs or inputs. Inputs. Okay. Data 3. Input. Okay. What the data 3 should be? So if we click data 3, yes, it's having some readings. Okay, so we have to readjust the readings. We have to enter the potential values. That is going to predict. Am I correct? So what happens? For example, so these are values. For example, these are values they are going to predict. Okay, 525. For example, customer, you can observe it. 525. So first I have to check for 525. As like that, as like that, as like that. So you have to enter each and every value and you have to find the output. Okay, so first I am going to check with 5 and 25. Okay, as like that, you have to enter each input. Okay, to finalize the output. So 5 and 25. 5 and 25. Don't change the format. So 5 and 25. But semicolon should be there. If we change the semicolon, all the readings should be done as one reading and we will not able to get the defined output. Okay? Okay. So I have initialized that data. I am going to check. Okay? I have initialized that readings in data 3. After that, what are you going to do? Go to network. Simulate. Input. Data 3. Simulate. Network. Okay, sir. So, yes, we are getting the readings like this. Same process, what is done in single layer neural network. What is the one main difference is, if you go into the here, okay, network, okay, that in the single layer we entered only 2 neurons. Okay, two layers. One is input layer, another is output layer. Not having any hidden layers. But here, we have to enter 3 layers. Okay, and parallelly, yes, we can able to check the neurons. First layer is fixed, and third layer is fixed. Second layer, we have made attend with 8 neurons. As like that, we have to make with 10 neurons, 11 neurons, 12 neurons. Okay, hence you get the graph for only one input. Okay, if I want to create, I want to check. Okay, so this is the input. Okay, so you have to copy it and paste in Excel. And again, what you have to do? So again, I want to create for. So again, I have to check for another input means no problem. Go for new. Okay, data 4 input create. That's all. No problem. But don't delete this network 1. So if you delete this network 1, that's all. Your problem. Your entire network is switched. That is, you don't get the results accurately. What's the problem is? So that network 1 is already trained. So with respect to that network only, if you feed this data input data, we are getting the output, predicted output. If you touch anything that network 1, the problem is finished. Okay, so don't touch them. Network 1 means yes, we can work with it, but go and simulate. That is data 4. Simulate network. Okay, here you can able network has been simulated and results are stored in mental data manager. Okay. This is the output. This is the output. This is the output for data 4. Okay, as like that, yes, as like that, you can add so many data here, and once if you enter the data and if you check it, that's all. Okay, again you cannot able to check it. So try to copy it. Okay, or try to keep it somewhere. Again go for another data, another input data, and find the output data. As like that, you have to fill the input data and you have to find the output data. Okay, and we have to make the comparison. Okay, that means we have to make a graph. Okay, so we have to make the graph, and finally that graph indicates. See, so we have to see, we have to just a minute. We have to indicate the graph, and after that you can able to say. So just here I have plotted between the external graph and predicted graph. See, here I plotted the graph between the experimental and predicted. Okay, so we have to draw a graph between the experimental and predicted. Automatically, yes, automatically it shows the correlation coefficient. Okay, so if you want to get the correlation coefficient, format, layout, trend line, display or square value, chart close. Yes, the heading or spire. Okay, we have to find all. That's all. Okay, we have to find all. As like that, we have to interlink all the parameters of the experimental value and predicted value, and we have to find the correlation coefficient. As like that, we have to carry for 10, 12, and we can go for 14, 16. Okay, and finally, we have to consult all the things. We have to consolidate all the things. Okay, so what happens? Yes, you have to make a practice. So what I am saying that you not having any assignments. Okay, not having any assignments. So each and every person want to make an attempt with the MATLAB software. Okay, so your category, all the groups can be, but all the groups can be categorized into different groups. Okay, with different batches with different dates. But on Friday, one day, all the 10 students want to assemble there, and I give the problem like this. Okay, and I fix the neurons 10 to 14 or 12 to 13. I give these two credits with different ranges. You have to work out it and get the results, and you have to plot the graph also, and you have to show it. Yes, and make an attempt with 8, 9, 10, 11, and finally I am saying that 10 is the best. Okay, if you done the thing, you will get the mark. Okay, good. Yes, sir. You can make an attempt with 10 neurons. So now make an attempt with 8 neurons. If you are having the software, yes, you can make an attempt with 10 neurons. You try to show it to me. If you are having any doubts, no problem.